Namaste students, I am going to discuss some important concepts in 8th standard mathematics today. Let you get involved whatever I discuss with you and note down the things, note down the concepts and important points whatever you feel in your notebook and be ready with your exercise, be ready with your textbook and with your pen. So, let us move further. So, I am going to show certain concepts in the diagrammatic form. Just try to observe it and try to join with me to discuss the concepts. So, first of all I have shown a geometrical diagram here. What is it? Yes, you are telling right, it is a point. So, let us name it as A. A is a point. I am going to name one more point here. Let us name it as point B. So, let us join A and B. So, what you call for AB here? Yes, you are telling right. So, AB is a line segment. Good. Now, let us move further. I am going to put one more point here. Let us call this third point as point C. Join these two. What we have get now? We have got the line segment BC. So, BC is also a line segment. Now, let us identify one more point. This point is point D and let us join CD and AD. What do you call for CD and AD here? CD and AD, they are another line segments. So, what you have got here by joining all the 4 points and by using 4 line segments, you have got a geometrical figure. What do you call for this? This geometrical figure is a closed figure, is it not? It is closed here. So, in this closed figure, what do you call for this closed figure? So, this closed figure is in a plane. So, it is placed in the plane. We can rename this closed figure in the plane as, we can call this figure formed by joining 4 line segments. This is the figure we have got this by joining 4 points in a plane and we have got even 4 line segments. Let us recall. So, we have found 4 line segments, we have found 4 vertices, we have put 4 points here. Let us move further. This is nothing but a quadrilateral, is it not? A quadrilateral is a figure. Let us recall the definition of a quadrilateral. A quadrilateral is a figure formed by joining 4 line segments in a plane, is it not? So, let us understand certain concepts on quadrilateral. So, let us move on to the lesson understanding quadrilaterals in your textbook. Are you ready with the lesson? I think you have understood the prerequisites, what we have to learn, what we have to be with before going in depth of the lesson understanding quadrilaterals. Let us move further. So, we can define it. Quadrilateral is a type of a polygon. It is a polygon because it has 4 sides. So, polygon is defined by using the number of sides. So, quadrilateral is a type of polygon. Note down the definitions. Now, let us move. So, let us classify before going in depth of the lesson. Let us classify these polygons based on sides. I have listed certain number of sides here. So, let us draw corresponding figures and let us name the figure also. You students, you too should also identify this table in your notebook. You should write it and draw the required figure and name the figure also. Number of sides are 3. What do you call for the figure? Draw the figure first of all. There are 3 sides. That figure is a triangle. What do you call for this figure? Write the name of the triangle. It is nothing but triangle itself. Now, if there are 4 sides, draw the figure, draw a rough diagram. Yes, you have drawn properly. Good. What do you call for this figure having 4 sides? Yes, you are telling right. It is a quadrilateral. Now, let us move further. If number of sides are 5, how do you draw the figure? Draw it. What you call for this figure? It is a pentagon. So, let us move further. If number of sides are 6, draw the figure. I have drawn it already. That figure is recognized by using the name hexagon. Students, write down whatever I am discussing with you so that it will be clear. Now, let us move further. So, I have listed some more sides. You should draw those figures along with me. What do you call for this figure in general? This is, if a polygon has 7 sides, it is nothing but a octagon. So, let us move further. If there are 8 sides, draw the figure. How do you name it? So, we can name it as octagon. Is it right? Now, if it has 10 sides, what do you name? How do you write the diagram? How do you write the figure here? What is the name of the figure? So, recall it. You have learnt it in the previous classes. I have drawn a figure having 10 sides. You can count it, and number of name of the figure is decagon. Deca means 10. Now, if it is 12, similarly you can draw the figure with respect to 11 sides. I have taken 12 here. So, what do you call for that figure? So, that figure you are telling right, it is dodecagon. Dodeca means 12 sides. Let us move further here. We have understood what is a polygon. So, what are the elements of the polygon? Let us list. I have drawn a polygon here. This is a polygon. How many sides it has? As you are telling right, it has 5 sides. So, what you call for the figure? As you are telling right, it is a pentagon. I have named those points whatever we have discussed previously as vertices, as vertex. What are the name of the vertices here? A, B, C, D and E, they are the vertices. Is it not? Let us list all those elements of this polygon. First of all, there should be vertex. There are 5 vertices here. So, vertices is a plural word of vertex. Now, there are sides. Let us name the sides. What are the sides here? AB is a side, BC is AE, I have drawn it here, AE is one more side, and DE, I have drawn it here, DE is one more side, CD, I have drawn it down, it is CD, and BC is one more side. How many sides are there in this pentagon? There are 5 sides. Along with these two vertices and sides, one more element we can find with respect to polygon, it is nothing but diagonal. So, let us draw diagonal. Later on we will define what are sides, what are diagonals and what are vertices. Diagonal AC is a diagonal, is it not? Because A has been joined with a point C or vertex C. Later on we will define it. I have drawn one more diagonal, name it. So, AD is one more diagonal, then CE, it is one more diagonal, then BD, tell with me so that you can easily recall it, and BE is one more diagonal. How many diagonals we have drawn? Count it. And one more kind of element of a polygon is angle. Angles of a polygon. Let us find where we can find internal angles here. Inner angle is angle A, or how can you read it? BAE. Angle D, I have shown it here. Then angle C, here we have shown. You too should mark in your exercise. Now, angle E, then angle B. These are different angles, and these are whatever I have listed here. What are the elements of the polygon here? Vertices, sides, diagonals and angles. So, let us move further. Elements of a polygon is broadly classified into sides and diagonals. We have seen what are sides there. Sides are nothing but line segments obtained by joining consecutive vertices of a polygon. AB is joined there. A and B, they are the consecutive vertices. They have been laid side by side. They are consecutive vertices. We get line segments by joining consecutive vertices. We call them as sides of a polygon. What is the diagonal then? With respect to sides, we can define diagonal as it is a line segment obtained by joining non-consecutive vertices of a polygon. Non-consecutive vertices are joined, we get diagonal. Is it not? Write down the definition in your notebook. We have got mainly 2 elements here, sides and diagonals. Sides are formed by using consecutive vertices of a polygon, and in converse, diagonals we can get by joining non-consecutive vertices. So, let us move further. What are the zones of a polygon? We can find mainly 2 zones. Interior zone, that the zone, the area which is lying inside the polygon. Exterior means whatever that lies outside a polygon. It has a border. Interior zone has a border. We can easily identify. Border is nothing but the sides of the polygon. For exterior, we have no such defined border because it lies outside. Hence, I have not drawn the diagram here. Let us move further. A polygon can be classified mainly into 2 types. What are those? Read in beside me, along with me. Polygon has been classified into regular polygon and irregular polygon. What is a regular polygon? Along with that, we will add these two also, convex polygon and concave polygon. Polygons are broadly classified into regular and irregular, convex and concave. A regular polygon may be convex, it may be concave. Irregular, similarly, it may be convex or concave. What are those? Convex polygon is shown there, it is a closed figure. Concave is also closed, but you can see how the structure shown in the diagram. You can see many such examples in your textbook. What are regular polygons? Let us define those. A regular polygon is one which is equiangular and it has all sides equal. Equiangular and equal sides. Which polygon has equal angles and equal sides, we call it as regular polygon. In contrast to this, if it has any one of these property does not hold good, that means to tell if it is not equiangular, if it has no such equal angles, then equal sides, we call it as irregular. A square is a regular polygon. Why? Why? Because it has equal sides. Is it not? It has equal sides. We will recognize the sides. I have recognized those sides, identify square has equal sides, but and even it has equal angles, because all angles of a square is equal to how much? All angles are equal to right angles, it is nothing but 90 degree. We can easily find that square is a regular polygon. What are irregular polygons? Irregular polygons are the figures having unequal sides and angles. The angles, they are not equal to one another, and even sides, they are not equal to one another. You can easily jot down the definition and you can recall it easily by comparing that same definition with the regular polygons. You can write the definition for irregular polygons. Let us see an example here. Rectangle is equiangular because all angles are equal to 90 degree, but all sides are not equal. Recall the definition of a rectangle. Later on, we will even define its properties also. We will list the properties. We can easily see it. It has equal angles, all angles are equal to 90 degree, but it does not contain equal sides. Is it not? Let us study one important property of polygons or quadrilaterals here, as we are somehow discussing on the concepts of quadrilateral itself. The first property, the important property or important feature is angle sum property. What does it tell? Let us recall. I have drawn a triangle here, is it not? What is the diagram drawn here? It is a triangle. Let us name the angles as 1, 2 and 3. Let us measure those angles by using these numerals 1, 2, 3. I am somehow tilting the same triangle. I am keeping the same triangle over it. I am calling it as 4 and this angle as 5 and the top angle as 6. We have to find sum of 4 internal angles of a quadrilateral. By seeing this diagram, you can see that quadrilateral into 2 triangles. Have you found it? And even I have found the angles inside it. Recall the angles whatever I have recognized here. In first triangle, I have shown it here. The angles are 1, 2, 3 and in the triangle that is placed above, the angles are 4, 5 and 6. You can easily recognize it and you can somehow measure the angles. You can easily find the angles whatever I have called. We have got, by placing these 2 triangles together, we have got a quadrilateral. Is it not? It has 4 sides. External sides you can see it. The side that is besiding the angles 1, 5 and 3, 4, that is nothing but a diagonal here. So, let us find the sum of 4 internal angles of this quadrilateral. It is nothing but sum of 2 angles of a triangle. I can somehow tell like this: sum of 4 internal angles of a quadrilateral is equal to twice the sum of 3 angles of a triangle. Is it right? There are 2 triangles, hence I can multiply it by 2 so that we can get sum of 2 angles of a triangle. In other words, twice the sum of 3 angles of a triangle. What is the sum of 3 angles of a triangle? All the 3 angles of a triangle measure 180 degree. You can recall it, you have studied in the previous class. 2 times I can write 180 plus 180 or 2 times of 180. What is 180 plus 180? Yes, you are telling right, it is 360 degree. Sum of 4 internal angles of a quadrilateral is 360 degree. Is it right? Note down the proof. This is proof 1. This is one kind of proof that we can easily understand angle sum property of a quadrilateral. Let us consider a quadrilateral having 4 angles 1, 2, 3, 4. I have drawn a quadrilateral here. I am going to recognize the angles as 1, 2, 3 and 4. I am going to tilt the same quadrilateral and placing all the angles together. See how it happens. If all 4 angles meet at O, let us make this quadrilateral having all the 4 angles to meet at O. I am going to recognize the angles by tilting the same quadrilateral, the first quadrilateral. I am placing it side by side so that I can get the angles at O like this. Where is O? I am going to recognize it. O is at the center. So, you can see O is at the center. What are the angles at O? You can see it here. O 1, 2, 3 and 4. There are 4 angles. Is it not? What are these 1, 2, 3, 4? These are the angles that were recognized for the original quadrilateral. If 4 angles meet at O, what happens? 1 plus 2 plus 3 plus 4. What it will be? At O, you can easily find. At O, it is a whole angle. What is the measurement of whole angle? Whole angle measures 360 degree. Therefore, sum of all 4 angles at O, 1 plus 2 plus 3 plus 4 is equal to 360 degree. Is it right? Are you following, students? Note down the thing, and why it is 360? It is based on axiom, because the measurement of whole angle at O, it measures 360 degree. Is it right? If 1 plus 2 plus 3 plus 4 is 360, what are these? These angles are nothing but the angles of the original quadrilateral. Therefore, sum of all 4 angles of a quadrilateral is equal to 360. This is one more proof. Write down the proof, understand it and discuss whatever you want to discuss with your teachers. I am going to draw a table here along with certain figures. Just note down, observe what is happening and try to fill up the blank rows. I have drawn one figure there. What is it? This figure is having 3 sides. What do you call for the polygon having 3 sides? A polygon having 3 sides is called a triangle. How many triangles are there in the above figure? There is only one triangle. What is the sum of all angles of a triangle? Sum of all angles is equal to 1 into 180, because there is only one triangle, it is nothing but 1 into 180. Is it right? How can I write? I will generalize it. For the sake of simplicity, I am going to write 1 as 3, because there are 3 sides, minus 2, let us take it as a standard constant. 3 minus 2 into 180. 1 is nothing but 3 minus 2. Is it right? In place of 1, I have written 3 minus 2 into 180. Sum of 3 angles of a triangle is 180 itself. We know it. So, let us move with one more polygon. How many sides it has? It has 4 sides. Is it right? Now, what you call for this figure? We have studied already. We call for this figure as quadrilateral, right? Now, how many triangles we can draw? I will draw a diagonal here, and none of the diagonals, while we should cut each other, while I draw triangles out of it. Let us have that condition here. Why I have triangle? Only one line. It is because let us not intersect any lines that we draw while drawing triangles. I have drawn a line here, so that I have got 2 triangles. Number of triangles formed in the figure is 2. What is the sum of all angles of this figure? It is nothing but 2 into 2 triangles. Is it not? 2 into sum of all the angles of a triangle, 2 into 180 degree. What is 2 into 180? 2 into 180 is nothing but 4. There are 4 sides. I have taken standard constant as 2, 4 minus 2 into 180 degree. Is it right? 2 can be written as 4 minus 2. In the previous figure, I have written 1 as 3 minus 2. Here, I am writing 2 as 4 minus 2. This minus 2 I have kept there also. Let us move further. New figure. I have written a diagram, a figure having 5 sides. What do you call for the figure having 5 sides? It is a figure which is nothing but pentagon. Is it right? Let us draw some triangles. by joining line segments. I have drawn a triangle by drawing a line segment there. I have drawn one more line, thereby I have got how many triangles in this figure? How many triangles you can see here? We can see 3 triangles. What is the sum of angles here? Sum of angles is nothing but 5. There are 3 triangles, 3 into 180. Is it right? There are 3 triangles, there are 3 times of sum of 3 angles of a triangle. How can you write 3? Since there are 5 here, 5 sides, 3 can be written in terms of 5 as 5 minus 2 into 180. Is it right? I can write 3 as 5 minus 2 into 180. It has 6 sides, and let us draw certain triangles here. How many triangles I have drawn here? Count number of triangles. 1, 2, 3 and 4 triangles. Sum of angles is nothing but 4 into 180. Is it right? Then how can we write 4 in terms of number of sides? 4 can be written as 6 minus 2 into 180. If there are n sides, we can easily write sum of all angles of a polygon having n sides. Can you generalize it? In place of number of sides, put n minus 2 into 180 is sum of all the angles. You can write the generalized formula here by using number of sides. I am repeating it. If number of sides are n, so in place of 6, in place of 5, in place of 4, in place of 3, I can put n minus 2 into 180 is the generalized formula to find sum of all the angles of a polygon. Is it right? Note down the diagram along with these generalized concepts. Let us solve certain problems based on whatever we have discussed till now. Find x in the figure. So, I have drawn a quadrilateral. One angle is given as 50 degree, another is 130 degree, one more is 120 degree, and the last one is x. We need to find it. How we can find? What is the method of finding it? Already we have studied by using angle sum property that sum of all 4 angles of a quadrilateral is equal to 360 degree, because we can form only 2 triangles without intersecting any drawn in line. Let us move further. We know that sum of all 4 angles of a quadrilateral is equal to 360 degree. Put equals in between. Now, let us sum those. The 50 is one angle, it is given. Another angle is 130 degree. The third angle is 120 degree. Fourth angle, we have to find it, that is nothing but x. Sum of all these 4 angles, as we have seen by using angle sum property, it is 360 degree. Is it not? Solve along with me, so that you can easily understand, note down and discuss with your teachers also, with your fellow students. Now, let us sum all these numbers, 50 plus 130 plus 120. What is it? The sum is 300 degree plus x. It is a unlike term. We can't add 50, 130, 120 with x, because these are numerals. It is a variable. You can't add numerals with a variable, because they are unlike terms. We have added only numerals here, only degrees, only 50, 130 and 120. It is the sum, that sum yields to 300 degree, and x I have kept as it is. So, it is 360 degree. Is it right? We have 300 degree on the left side. So, let us transpose it to the right side. What happens? X is equal to 360 degree, and let us transpose 300 to right. What happens? It becomes plus 300 becomes minus 300. Is it right? Whatever the quantity that is in the left side, I am moving it to the right side. So, it is nothing but a kind of transposition. X is 60 degree. So, we have found the fourth angle as 60 degree in this quadrilateral. Students, note down whatever I am discussing with you. Similarly, let us find x in one more figure. So, I have drawn a figure here, and the angle that we have to find has been shown as x in the figure itself. You can identify, and one more angle has been recognized as 70 degree, and the external angle is given. It is 90 degree. What you call for the angle having 90 degree? So, yes, you are telling right. This 90 degree is otherwise called as a right angle. As shown in the figure, if a ray like this stands on a line on another ray, sum of adjacent angles is equal to how much? The sum of adjacent angles is equal to 180 degree. Already one angle is given. What is another angle? Another angle should be 180 minus 90. We can easily find one more angle based on if a ray stands on a line, sum of adjacent angles as shown in this figure should be 180, one is 90, another should be 90, because 90 degree plus 90 degree should yield 180 degree. The third angle we have found, but we need to find x based on what we have studied by using angle sum property. Sum of 4 angles of a quadrilateral is equal to 360 degree. Good. Now, let us write these angles by summing them. 70 degree is the first angle, 60 degree is another, and another angle is 90 degree. By using axiom we have found it. The fourth angle x we have to find. All these has the sum 360 degree based on angle sum property of a quadrilateral. Let us add only like terms by leaving unlike term as it is. 70 plus 60 plus 90, the sum is 220 degree plus x, because we can't add x with 220, because x and 220 they are unlike terms, plus x is equal to 360 degree. So, 220 is in the left side. So, let us move it to right side. So, what happens? Plus 220 becomes minus 220. Is it right? 360 minus 220 is 140 degree. Value of x, it is measuring 140 degree. Is it right? Note down, students, understand what we are discussing and discuss the same thing with your fellow students. So, similarly, let us find x. I have called x here also. So, there is a regular pentagon. What is regular? Can you recall? What is a regular polygon? A polygon having all sides equal. Equal sides are shown by drawing double lines on the sides. All these sides are equal. It is a regular polygon. Regular pentagon is equiangular, because all angles should be equal and all sides are equal. So, it is equilateral also. Now, all angles are equal. If it is x, it means that all angles are equal. Sum of all 5 internal angles of a pentagon is equal to 5 minus 2, n minus 2 into 180. We have already studied, we have already discussed the same concept. If there are 5 sides, 5 minus 2. If there are n sides, it is n minus 2. Therefore, sum of internal angles of this pentagon is 5 minus 2 into 180 degree. How many angles are there? X, x, x. On 5 times we have to add x, because there are 5 internal angles here. Is equal to 5 minus 2 is 3 into 180 degree. 5 x plus x plus x plus x 5 times is nothing but 5x is equal to 3 times 180 degree. 3 times of 180 degree is 18 3s are 54. So, it is 540 degree. So, let us divide by 5. So, 5 1s are 5, let us cancel it. 5 1s are 5, 5 8s are, this 4 is smaller than 5, 5 8s are 40. Therefore, x is 108 degree. Is it right, students? Understand the problem, what we have done till now. What we have learned till now? We have learnt about polygons. We have classified polygons, diagonal of a polygon. Now, we have even classified a polygon briefly, and we have studied in 2 methods what is angle sum property of a polygon. Now, we have solved even some of the problems on quadrilaterals by finding x. Solve these problems, find x in the figure. I have identified different angles. I have identified x, x and 30 degree, and it is a polygon. How many sides it has? Identify, count number of sides it has, count the sides 1, 2, 3, 4 and 5 sides. What do you call for a polygon having 5 sides? What do you call for it? A polygon having 5 sides is a pentagon. Is it not? Sum of internal angles of the pentagon is n minus 2 into 180 degree. What is n here in case of pentagon? Number of sides are 5. Sum of interior angles of a pentagon is 5 minus 2 into 180 degree. Is it right? Find x, and they have given external angles here, it is 70 degree, and this external angle is 60 degree, and x, there are 2 x's, 2 angles are equal. Based on the angle sum property, solve this problem. Can you solve this? You have to solve in exercise in your textbook. of exercise 4.1. Solve problems 1, problem number 1, problem number 2, 3, 5 and 7. These problems are similar to what we have discussed. Thank you, students.